The purpose of this video is to review an exploration that you were offered on Solving Equations Basics, where there were some picture models and you were supposed to find the value of each star, for instance, or knowing 2 hearts balanced with 8, what would 1 heart be? Or if 2 hearts balanced with 8, then what would 3 hearts be? So we will conclude what should have happened on the top, and then we will get into the basics of how to solve algebraic equations using proper algebra notation and the big ideas surrounding that. If you know that 2 circles and a star should be balanced with 5 circles, how I approach the value of each star is I try to see, okay, 2 of these essentially cancels out 2 of those. This would take up the same amount of weight on a balance beam, for example, as these would, which means that the star must represent 3. Here's what happens using algebra. I have 2 circles plus an unknown number. I'm going to let the star represent x, or a variable, and that is equal to 5. Using mental math, I can see that my solution is correct because a 3 substituted right here would make that equation true. If I apply the same reasoning to the next one, 3 of these would cancel out 3 of the others, and that would leave me a star representing 1, 2, 3, 4. If I check my work using algebra, 3 circles plus an unknown number is equal to 7 circles. I see that my solution is correct because if I substitute a 4 right here, 3 plus 4 would be equal to 7. What you'll notice in the other ones that make it a little bit different is here a variable had a constant number added onto it. Same in this example. But here, if the hearts would represent the variable, that's 2 unknown values, and I see that it's equal to 1, 2, 3, 4, 5, 6, 7, 8 little squares. I don't have another value that's being added on with the variable. I see I have a variable and I have a coefficient as well. So 2 times something would be equal to 8. And using mental math, I know that the value of x has to be a 4. But here's how I can prove it. Since there are 2 of these and 8, I can say, well, this heart would represent these 4, and this heart would represent those 4. So it's kind of like I'm taking the 2 hearts and I'm dividing that 8 evenly between the 2. In a similar scenario, 2 hearts is balanced with 8, and it wants to know what about 3 hearts. I can use this step because the original situation is the same, knowing that 1 heart is 4. If I tripled the amount of hearts, there's 3 times as much. I can do 3 times as much of 4, which would be 12. If I check my work the way I checked my work up here, this heart would have those 4, this heart, these 4, this heart, these 4. So you may be looking at these equations and thinking, okay, Ms. Halpern, great, I passed 3rd grade. I know how to solve for unknown numbers just using my basic math facts. But when the numbers aren't whole numbers, when the numbers are negative, or when the numbers are decimals, or when the numbers are fractions, or when it's not just one step, or you don't have a picture to accompany your equation and you don't get that visual, you need skills in how to approach algebra. And that takes us to the big ideas of solving algebraic equations. We discussed in class and in previous videos that when you solve an equation, that means you find what the variable is equal to. And there are three big ideas that are associated with this. First, it is essential that you keep balance, because we know that the balance beam represents equality. You have to maintain that balance. Another goal is you need to isolate your variable. Isolation is what many of us are experiencing right now because we're out of school due to taking precautions with a new virus. Isolation means to be alone, to be by yourself. So we want the variable to be by itself. And also we're going to be using inverses to accomplish this. Inverses would be, there are inverse operations. For example, multiplication and division are inverses of each other. Addition and subtraction are inverses of each other. And you could see that happening in these picture examples. When I showed these two canceling out with these two, crossing off in a picture means take away, means subtract. So what I was doing was the opposite of addition to help me work backwards. Over here, I was talking about taking the 8 and splitting it between the two. Splitting is division, and division is the inverse of multiplication, and that is multiplication. When a variable and a coefficient touch, it means that they multiply together. So inverses have already been at play in some of these examples. This is available as a PDF file to you on Google Classroom to print, if you have the ability to print, and I'm going to mark a few key points. First, we know that equations show equality or balance, and when we are modeling equations, we're going to use a balance beam. For example, this equation, using the previous key that we've used on other assignments, the rectangle would represent a variable, the unshaded squares would represent positive constants or adding. So the equation that is modeled is x plus 3 equals 7. And in your head, you're probably already thinking that x is a 4. That's because we all passed first grade. However, I'm picking easy equations to show you the algebra notation, because the algebra notation is going to be what is new. So you already know, in mentioning the big ideas, that the goal is to isolate the variable on one side of the balance beam. It doesn't matter which side. To do this, other items like constants have to be removed. So what you see in the second illustration is I removed the 3 constant values. But if I remove those, I lose equality and the balance beam tips. Therefore, if I removed a constant on one side but not the other, then the balance no longer represents equality. Therefore, what you do to one side of the balance beam or equation must be done to the other side. So 3 were removed from the left-hand side, and 3 were removed from the right-hand side. Now I can see that the variable x is balanced with or equal to 4, and we already knew that using mental math. Once the variable value is known, the balance should still represent equality if the value is substituted into the equation. Substituting in math is exactly what substituting means in school. A substitute stands in place of a teacher. And so in this case, the value of x we're saying that x is equal to 4, that value can stand in place of the variable. And when I do that, I can see 4 plus 3 is 7, and that is equal to or balanced with 7. So I know that my solution of x equals 4 is correct. Going back to the big ideas that we mentioned, we have found the variable's value. We have done that by keeping balance. What we do to one side, we have to do to the other side. We have successfully isolated the variable right here, and we have used inverse operations to do that. The original equation had addition, and I used the opposite, subtracting 3. What I did to one, I did to the other, subtracted 3, and that is how I successfully solved for the value of x using algebra notation. And I was able to check my work with mental math because it was a basic equation. And these will be big ideas that we use moving forward.